I'm Anil Kumar, sharing with you a test question on limits and continuity. We need to sketch the graph of f of x, which is equal to absolute value of x divided by x times x squared minus 1, and then determine whether the function is continuous, right? So let's begin with sketching this particular function. We have f of x equals to absolute value of x. Now, what is absolute value of x? Well, the absolute value of x can be defined as, let me redefine absolute value of x here. Absolute value of x is actually equals to x if x is greater than or equal to 0 and is minus of x when x is less than 0. That means we could write this function as a piecewise function, correct? So we'll write f of x. So we know that f of x is a piecewise function. Right? So the pieces are one where x is greater than or equal to 0, that side. The other one is for x less than 0. So let us redefine this function as a piecewise function. So we could write f of x as equal to two pieces. The first one we'll write when x is greater than or equal to 0. So at that time, absolute value of x is positive x. So it is positive x over x times x squared minus 1. Now you can cancel this off, and then you could write x squared minus 1, right? So it is x squared minus 1 when x is greater than or equal to 0. Perfect? Now the second piece is when x is less than 0. At that time, absolute value of x is negative x. So we'll replace this by negative x. So we have negative x over x, and we have x squared minus 1, and that gives us negative of x squared minus 1. That is when x is less than 0, right? So as you can clearly see here, we have two different pieces. One when x is greater than 0. The other one is when x is less than 0, right? Now it is simpler to sketch. So now let us sketch this. Let us say this is y-axis, and here we have x-axis. So we'll just make approximate graph here. You can always take a proper graph paper, plot some points, and then sketch a neater graph. So when x is greater than or equal to 0, we are talking about this side, right? If I substitute 0 here, I get 0 minus 1, which is minus 1. So we get a point here. If I substitute 1, I get 0. If I substitute 2, then 4 minus 1 is 3. So somewhere kind of, let's say like this. So it gives you a parabola which is opening upwards, correct? From minus 1 going upwards like this. So we have this right side of the graph starting from minus 1, and this point was at 1, 0, right? And this point is at 3. I mean, when x is 2, this is 3. So we got 3 points to plot. Now let's plot the left side of this piece. If I substitute x equals to 0, let me do it in a different ink. Then 0 is not included, so we'll use that point as a whole, right? So this one, the first one which we did, is a filled-in circle, right? It's a filled-in circle. Now for the left side, when I substitute 0 here, I get minus of minus 1, which is plus 1. Let's say this is plus 1, but it's an open circle, right? Since this is not included. And that's why it's a function, okay. Now if I substitute minus 1 square is positive 1. 1 minus 1 is 0. So we get 0 here. So at minus 1, we get 0. At minus 2, we'll get 2 square minus 2 square is 4. 4 minus 1 is 3. Minus of 3. So it'll be like minus 3. So it is a point which is kind of here. So what we see here is a parabola which is kind of like this. Is it okay? So that's what you get. So at minus 1, we have x-intercept. And at minus 2, we have a value which is minus 3. Okay. So we have a parabola which opens upwards. So that is the sketch of the graph. This is the x-axis, and this is the function f of x. So we've done the first part. Now let's look into whether the function is continuous or not. So clearly from here you can see that there is jump discontinuity, right? So we have jump discontinuity. So the function is not continuous, right? So when we say a function is not continuous, let me explain here how we should explain it to get full marks, right? Now, talking about continuity, we say it is discontinuous or it is not continuous, right? It is discontinuous. Reason for being discontinuous is that the value of function at 0 is not equal to the limit of function at 0, right? In fact, what is the value of the function at 0? Let me rewrite the value of function at 0. F of 0 is what? We defined for x greater than or equal to 0, the right hand side, which is -1. So f of 0 is actually -1. Now what is the limit of the function at 0? So let's figure that out. So limit when x approaches 0 from the left side. From the left side, if you approach, the limit is +1, right? So this limit is +1. But the limit when x approaches 0 from the right side, in that case it is -1, right? So in fact, what we see here is that the limit as x approaches 0 for the given function does not exist, right? Well, in this case, since the limit does not exist from there itself, we could have said that the function is not continuous. So for a continuous function, it is necessary to have the limit. That's the first part. But anyway, we kind of explain the second point also, because there could be a situation where the limit may exist and the function may not be continuous, right? So in this particular case, we can say that since limit does not exist, the function does not exist at x equals to 0, right? As x approaches 0, or you can say at x equals to 0, the function is not continuous. I hope that part is clear, right? So the function in this case is not continuous since the limit does not exist as x approaches 0. I should say as x approaches, I should make an arrow here, right? So as x approaches 0, that is the reason. Since the limit does not exist, right, and a value does exist, the value at 0 is -1, right? So either way, you could also say since the limit is not the same as the value of the function at 0, it is not continuous. So anyway, that is how you could explain how the function is not continuous at x equals to 0. And the type of discontinuity which you see here is jump discontinuity. I'm Anil Kumar, and I hope that helps. Thank you and all the best.